So hi everyone, I'm Stephanie. I am a program manager on the Azure Resource Manager Deployments team, working on Bicep right now, and Alex is also a program manager on the team. I'm going to stop my video just in case my computer can't hold on to everything right now. All right, before I start, I want to ask if other people have experience. Does everyone have experience with Azure Resource Manager, whether it's Terraform, ARM templates, Bicep even?
Small bit.
Small bit? Okay.
Yeah, you used to use Terraform to kind of deploy most of our stack, to be fair.
Okay. So pretty knowledgeable, I'm guessing. Okay. Then I'm going to assume a lot of basic concepts are known. So I'm going to just start then. So Bicep. What is Bicep? Bicep is a higher level representation of ARM templates. ARM templates can be very verbose and takes a lot of effort to just learn the specific language to author a file. So what we did was create Bicep to be able to make this experience easier, and I'll go more in depth in the following slides as to why we put so much effort into improving and authoring this experience. Before I go on, if anyone has any questions, definitely put them in chat. Alex will be checking, and if there's any other questions, we can do questions and answers at the end. So from Bicep, you use this command bicep build, which transpiles into an ARM template code, which creates a deployment resource, and we'll go through the validation to make sure your deployments are as successful as possible before they go to Azure Resource Manager and deploy to Azure. So why Bicep? There are already so many ways to deploy resources to Azure. You can use Portal, PowerShell, CLI, Terraform, as you guys are experienced with, and just other options available elsewhere. A lot of people ask, why are we creating another way to deploy resources? We see a lot of ARM template usage today with our users, as they're by far the most widely used tool to declaratively deploy resources to Azure. It's a large customer base using ARM templates, despite how difficult it can be to author them, because it's a very powerful and effective tool. So we wanted to take away a lot of the pain that comes with writing and developing ARM templates and turn it into a simpler authoring experience, hence Bicep. We want the existing experience to be better for current users and make the ramp up a lot easier for new users as well. Benefits. One of the biggest benefits to Bicep is much simpler syntax. It's so much easier to author and much easier to read as well. So here we're looking at a Bicep code and ARM template code creating the same resource in Azure Resource Manager. As you can see on the right-hand side, the ARM template has so much noise that it's literally falling off the page. Lots more brackets, things in quotations, in parentheses, and this is just necessary to declare it in JSON language. We had to have our ARM template language to be embedded within JSON to make it work, and as you can see, it's hard to fully grasp what's in this template through all the noise. JSON is a data structure, not a programming language, so it makes it a challenge to author. So we're redesigning the front end of the language to make it easier to work with the existing ARM template language. So with Bicep, we want to move it past the JSON and give it its own file to live in. If you're familiar with ARM templates, you know that one of the biggest advantages to using an Azure native language like Bicep is day zero support. So for a quick explanation, this is a snapshot of a lot of the services available in Azure, and this list is growing every day. With other tooling, there's an onboarding process in which we have to create a client to work with new services, resource providers, all of the things that are available in Azure. So we don't have to enable anything first for it to be available to be consumed and deployed with Bicep and ARM templates. Day zero support is one of the reasons why native tooling can be much more reliable. So with Azure growing and improving so quickly, with features and services being added all the time, Bicep and ARM templates can keep up with the day zero coverage. Modularity. This is one of the things that was really challenging to do with ARM templates. There were linked ARM templates to be able to sort of rough patch files together, but we wanted to be able to fundamentally fix that. So what we've done with Bicep is create a kind of first-class modularity and first-class code reuse, which is the standard for most programming languages, to be able to break down code so other people can use and reuse files. And we wanted to make sure that Bicep supported this. And I'll show a little bit in the demo. Toolability. A really big strength with ARM templates that our team has put a lot of work into is toolability. So what this means is we do as much as possible to validate as you're authoring within VS Code. We expanded the capabilities for ARM templates like syntax highlighting and better IntelliSense to make sure that that experience is better all around. We found that tooling is one of the most basic and fundamental things to the design of the language and compiler. It has to be designed to work and fail well for the user. So everything we're building into Bicep is with tooling in mind to have it work with the language server. Because of this, Bicep has rich IntelliSense and validation today, which we're working on continuously, making it better and more accurate with each version release. Our tooling is built much more like a programming language and will feel similar to authoring C# files. We've gotten insight from the people who have created other programming languages within Microsoft. Another benefit is no state management. If you're familiar with Terraform, you know they're reliant on state management as a snapshot of what would be seen in Azure. In ARM templates in Bicep, we're able to leverage Azure as the state itself. So you can perform a deployment on any device and can always pull the state to run the tool with it. This is one of the main benefits to using an Azure native language rather than external languages like Terraform. So goals. To reiterate our goals, we want to reduce the current pain of authoring ARM templates, which we've been able to achieve so far. We wanted to lower the barrier to entry as much as possible. We wanted to be a transparent abstraction, which day zero support achieves, and we wanted modularity, which I referred to. We also defined some non-goals. These are just as important as the goals, if not more. We have no intention on having Bicep be the only language out there for cloud users or Azure users. Whatever way you're interacting with Azure or helping your customers interact with Azure, as long as you're happy and successful in what you're trying to achieve, we want that for you. So like Alex said, we are investing a lot into Terraform because we want to make sure that the people who are using Terraform and finding it helpful can get that support as well. ARM templates are able to help users out in achieving their goals in Azure, and Bicep is just an improved way to use ARM templates. We're also not trying to be a general purpose language. There may still be data processing tasks outside of your template you'll need to do with your own scripting and pipeline, but you can pass those outputs into Bicep or pass outputs from Bicep into those tasks as well. So basically, there's no goal for Bicep to fill all of these gaps and steps that might be taken to create a general purpose language. So where we are, version 0.1 and 0.2 was last fall. About a year ago, this was our experimental version trying to navigate how we want everything to be improved. 0.3 was back in March, and this was our production-ready version. It had full ARM template parity, so that was really exciting. And today, version 0.4 was our first post-production release, emphasis on quality and stability, speeding up the inner loop, and recently we released the private module registry. So that was really cool. And we are currently working on a public module registry, which we will release in 0.5 soon. And that would be pretty cool. So keep your eye out if you're following. All right, before I go into the demo, does anyone have any questions? Cool. Let me switch over to VS Code. All right, can you see my window? Awesome. Okay, so I'm in VS Code right now, and here we have the Bicep extension. If you just search Bicep, this will come up. Our most recent release was 0.4.1008. And you'll get updates automatically from VS Code, so they'll be able to manage that for you when you install this. Okay, cool. So we could get started authoring an app plan here. So you start off with the resource keyword, just like with Terraform, and you give it what we call a symbolic name, which is basically just a variable reference. You can put whatever you want here. I'll put app plan, so I know what I'm creating. We're creating an app plan. IntelliSense pops up to ask me what type of resource I want to create. Each option here tells us exactly what resource type we want, as well as the API version listed as well. I can start typing what I want, which is a server farm. And as you know, when authoring a Bicep file or template, you'll need to know the specific names of each resource you're hoping to deploy, which can be a bit of a learning step. So knowing the fundamentals of Azure Resource Manager is very helpful when writing Bicep files and ARM templates. So right away, I will hover this, and this is what our IntelliSense will tell us. I'm told that we need the name and location properties. So I'll give this a name. I'll call it Steph site. And I'll add a location, which will be my resource group location. So we don't have to put in or hard code any location here. After this, I want to define a few more properties. So I typed control space here to get this dropdown of other available properties. This menu is generated from what the resource provider gives us. In this case, it's Microsoft.web. They define the APIs in Swagger, and we consume that to generate this information off of what they defined. This pretty much shows that we're a thin abstraction. We're not creating this list of properties. This is what we get from the resource provider directly. So I want to set the kind, and we want to create a Linux app service plan. And for the SKU, this has to be an object, and I just want a name, which I'll choose B1, one of the most basic tiers. We'll also have to add properties, which is another object, and I'll put reserved, true, so that the app plan can run on Linux. I want to also write some parameters because I don't want a static resource name. So param is the keyword I want to use. And I want to use the symbolic name prefix. And it will be a string type. And I will edit the resource name here using string interpolation. I could also choose for the SKU to be parameterized as well. So I will SKU here with the string, and I will give it the default value of v1. And I can replace the hard-coded SKU here with the parameterized SKU. And the last thing we're authoring in this app plan here is an output. We'll call it plan ID, which is also a string, and then reference the app plan here, which this pops up with the IntelliSense app plan dot ID. And we can output this particular property. So now we're going to switch over to our main Bicep file, which is what we're going to use to consume the module we just wrote. So the first thing to do is set the target scope, and I'll set it to a subscription. And the next thing we're going to do is create a resource group. So I'll create another raw resource, call it RG for resource group, and then IntelliSense will pop up again. And I'll just pick the most recent version for resource group. Again, I need a name and a location. So I will give it the name FNRG. So it can deploy to my own resource group. And I don't want to hard code this location either. So I'll have it just point to the deployment location. Now I want to refer back to the app service plan we just created. And we'll use the keyword here, module, and call it app plan deploy for our own reference. And I'll get some IntelliSense on what we can consume as a module based on type. We'll choose here the app plan.bicep file that we just wrote. And here are the properties that we can set. We can choose depends on, we can name it, add more parameters, and set the scope, which is where you're going to deploy the module. So the module is just a Bicep file and can be deployed to any scope in Azure, and we want this scope to add a resource group. So I will set the scope. Coincidentally, we just created a resource group. So this will pop up as RG, and it's as simple as that. It also needs a name. I'll call it app plan deploy. And I want to set some parameters. We have two potential parameters we configured, and only the name prefix is required because we already set the SKU. If I wanted to overwrite the SKU, I could give it a better SKU, but that's unnecessary for me. So I'll set the name prefix to Steph, and this is all I need to deploy for the app service. So this block of code is integral to modularized code, an important concept to learn when you want to consume modules for future use. We've tried to make it easy and straightforward to simplify modularization and help you manage them more efficiently. So the last thing we're going to want to do is instantiate the website itself. I have another Bicep file here. I don't know why it's set to batch, but our extension does this really cool highlighting, really cool colors here. So that's pretty cool. And I don't want to go in depth into this file because it's a pretty standard resource definition for a website. And there are a bunch of parameters here that have been set up for me. So it's going to output some information when I deploy. So specifically, this website deploys Docker images as its source for application code. So we're going to reference an image from Docker Hub in our main Bicep code. So switching back, we need to author another module, which I'll call deploy site, and I'll reference the site we just looked at. This also needs a scope. So I will set it to the same scope, RG, and it needs a name, which I'll call dev site. This needs some parameters as well. And IntelliSense will show us what is required based off of the site.bicep file. So first we need the app plan ID. Referring to the raw resource above, we just created this app plan and the website will have to sit on top of this app service plan, so we have to tie them together. So in order to do this, we'll have to grab the output from the app plan module. So app plan deploy dot outputs dot plan ID. Everything just pops up with IntelliSense. All right, we also need a Docker image, which I will label as nginxdemos/hello, and a Docker image tag as latest. We also need a name prefix, so I'll do it right stuff again for myself. And that's it for that. So we also need to set an output, which we want the site URL. So we'll make it a string, and this will be deploy site dot outputs dot site URL. So when this template runs, it will output the URL and I can go directly to the site itself. Now this is all we need to create a website using a Docker image, and we can deploy these files from here. However, say we want to loop through deploying several websites. What we're going to want to do is create a websites variable with the keyword var and websites. And the first website we want to do is maybe do a fancy website with the tag latest. And then the second one, we'll create a plain website. We'll call it plain website and the tag plain text. And that's all we need for the variable. We'll also need to edit the module itself. So this mainly stays the same, but we'll have to loop through the website. So next to site.bicep, I will put a bracket here. So for site and websites, that is how we will loop through the websites. And we'll have to change some of these names. So for the name, we'll use string interpolation again as site.name. For the Docker image tag, we'll change it to site.tag. And then for the name prefix, again, we could do site.name so that they will change for each of the websites that we're creating. We'll also have to update this output. Instead of one string, we'll have to do an array, and then we'll loop here as for site, I, and website. Change this deploy site to I so it goes through as an array, and close that bracket. So this is all we need to deploy this. So we'll go to terminal. And you can use either Azure CLI or Azure PowerShell, whatever you're more used to, but I'll use Azure CLI. So I'll type AZ deployment sub create. Depending on what you're deploying or where you're deploying, it can be AZ deployment tenant or resource group or MG, just whatever scope I targeted in Azure, which I set it to subscription. /f main bicep location East US, because that's pretty close to where I am, and -c. So -c will run our what if, which will predict our deployment for us. When we run what if, it'll show us what we're going to do. If there are any errors in my code, they're going to be caught because we do some further validation. So if it looks good, we can then choose to play it. All right, while this is running, does anyone have any other questions?
Yeah, if the resource group already exists, does it just leave it there? It doesn't create it again? And similarly for the other resources.
Mm-hmm.
Does that make sense?
Yes, yes.
Yeah, the resource group, any resources in the ARM template are, or in the Bicep code, will be idempotent. So they'll all behave kind of the same way. We don't, there are certain cases where we understand a little bit more about what a resource group is, but at the highest level, we think of all these things as just resources, and they all should work semantically the same way. Sometimes APIs will not behave well and not be idempotent when they're supposed to be. And there can be issues like that, but those are constrained to a particular resource type within a particular resource provider. And if you came to us and said, hey, why is this happening? We would suggest opening a support case with that team or help resolving it that way.
Yep. And so with this what if command, it shows the resources that I want to create. But if, say, the resource group was already created, it would just say no change. That would read that in the deployment. Does that answer your question? Cool. So this will just run as it does, and it'll take a couple of minutes because you're creating a website or several websites. Any other questions?
And one thing I just wanted to call about what Stephanie is doing, we talked about at the beginning that Bicep is this transpiled language that goes from Bicep to ARM templates. And when we first started the project, you would have to actually do that transformation yourself by running this Bicep build command. But we do our best at this point, basically, to hide that JSON representation from you as much as possible. So what Stephanie did was point the deployment command to a Bicep file, which turned it into an ARM template just in memory, and then sent it to Azure. So there was no ARM template.json file written onto disk at any point. We just kind of abstract that away from you. We try to treat this the same way that TypeScript treats JavaScript, very similar relationship, or C# to the CLR, really the same idea.
There's also a chat in the a question in the chat as well. You can see that.
Is the name in the module the name of the deployment, so in the portal against the RD deployment, or is that name something else? Stephanie, did you want to answer that, or would you like me to answer that?
Can you answer that?
Yeah. So that module.name property is the deployment resource itself. So it's kind of the one place in Bicep where the abstraction leaks through a little bit. That name is not going to be attached to the names of resources. It's for debugging. If a particular module fails, basically, you can see that name represented in the portal. Our goal is actually to, at the very least, make that name property optional, so we can generate a name for you dynamically, so you don't need to worry about it. We're even discussing making it not an allowed property at all, and we always generate a name for you, as long as we have confidence that we can create a good kind of paper trail of deployments so that you can debug and have traceability and all that sort of stuff. Did that answer the question, Chirag? Cool. The next question, can you see the ARM template file if you want to? Do you want me to take that one, Stephanie?
Mm-hmm.
So if you want, you can always run AZ bicep build or bicep build if you have the CLI itself on your path. We integrate bicep into AZ CLI, so it kind of has its own version of CLI that it can call. So most people will just use bicep through AZ CLI or Azure PowerShell, and they may not have CLI on the path, or the bicep CLI on the path. Anyway, so you can run this build command, AZ bicep build, to get the ARM template at any point. Can you add protection or roles that can be applied to protect pre-existing resource groups from bicep changing it? Also, is it possible to use bicep to detect configuration drift? So when it comes to locking resources, there's a kind of generic platform construct called a resource lock, which you can add to any resource. And that is either a read-only or a do not delete lock. The tricky part with that resource is that it's stored at the same scope as the resource. So usually if you have permissions to modify a resource, you probably have permissions to modify the lock. So what the lock ends up being in most cases is like, hey, are you sure you want to modify this resource? There's a lock on it, maybe you don't want to touch it. But usually that's not like a permanent airtight solution. There is a notion of something called deny assignments, which can be leveraged through either the managed apps service or the blueprints service, but it's not kind of generally available. So it's not as kind of useful as an option for this sort of thing. So there's not a ton you can do other than manage permissions accordingly. So what we typically see at most organizations is some pipeline with some service principal that has some scope down permissions to only do what it's allowed to do. And you want to be careful not to have that permission set be broader than it needs to be. Obviously that's easier said than done, but that's kind of the general operating model. For configuration drift, what if is going to be the kind of best way to do that right now. So the what if command that Stephanie showed will compare what that template looks like right now with what Azure currently looks like right now and produce a diff response accordingly. There's a effort underway called Deployment Stacks, which is a new service that will have kind of a better configuration drift story where you'll be able to see the difference between two snapshots and you'll be able to see kind of how your deployment stack behaved over time. I'll put a YouTube link in the chat if you want to learn a little bit more about stacks, but that may be something that you want to look into for that one. Jazz, let me know if I answered that fully or if you'd like me to keep talking about that one. Cool. Kevin, is there any reason why Bicep wasn't any language to ARM templates such as CDK, Terraform CDK or AWS CDK, which both allow writing any language and creating the templates? Great question. So when we started this effort, so we were just working on ARM templates and trying to make them better. Because the usage of ARM templates is so, like, I can't emphasize enough how much ARM templates are used in comparison to other tools. It's surprising given the kind of external, like, mind share of ARM templates in Terraform and so on. So we were working on ARM templates just to make the experience better and lower pain thresholds for what people were doing today. And we explored all options because we knew this was a big investment. And we wanted to make sure we kind of evaluated everything thoroughly. So our two kind of main things that we were focused on potentially doing was either kind of the Bicep approach or the CDK approach. There are a few reasons why we didn't end up going down that route. The main ones are our target audience that was authoring ARM templates are not familiar with traditional programming languages. So usually it means they would end up learning some programming language. They might have a PowerShell or a scripting background, but they didn't always have a traditional programming language background. That we were a little wary of, but we don't think that would have been like the deciding factor in going CDK versus Bicep. What is the real challenge, and it's a subtle one, is that when you're doing CDK, you're existing in two worlds. You're existing in the let's say the TypeScript world, or the .NET world, and the expression language of the underlying language. So ARM templates themselves are a language. In CloudFormation, there are expressions, as I understand it, but I don't know that as deeply. So you need to understand, like, okay, am I in the limited confines of the ARM template expression language, or am I in the broad opportunity space of TypeScript or .NET and stuff like that? And managing those two worlds and explaining the semantics of how you exist within those two worlds is not straightforward. And that's where CDK can become challenging. Or if there's like a tool called Farmer out there that does this as well. They're really useful, but you need to understand more deeply what you're doing. So that's why we ended up going with the Bicep route, which is basically just a better expression of the current ARM template language rather than like a new language on top of it. It does not mean that we would not like a CDK in the future. It would be really cool if there was a CDK and there were other languages besides Bicep for doing this sort of authoring. We think the Farmer project is really interesting, and we try to help them where we can to make that project efficient and useful. And it would be great if there was a version for it in TypeScript and any other language that we wanted to support. So that's like the full history. I'm happy to answer any other questions about that if it's helpful, but that's kind of where we were when we made that decision. Cool. Any other questions?
I don't know if it's going to be part of the demo, but can you show the visualizer? Because that's quite nice.
It's a pretty simple deployment here, but yeah, just it's a pretty cool visualizer. I know that we have a video on YouTube in which Xbox recently shared their code base, and their visualizer just has so many resources here. It's like everything's pointing to everything. So if you want to see a more advanced version of that, you could go look at that.
And what I really like about the visualizer is it's kind of just an expression. It's what the language service sees, like quite literally. So when we're evaluating dependencies and talking, trying to figure out if the code is valid, basically, this is kind of the internal picture of what the code base puts together. This is the object model of what we understand your code to look like. And so it's really great to be able to just like spit that out and see that pretty easily. And it's always accurate. So as you edit code and make changes, the visualizer will reflect that. It's a good way to understand how the dependencies are being put together, when a dependency is there versus when it is not. So we try to be smart and determine dependencies. Like if we see you reference a resource symbol in another resource, we throw a dependency on that. So like where on line 9 and on line 28, where the scope is RG, we know that there's a dependency to that resource group at that point. So that all gets reflected in the visualizer as well. So it's pretty cool. And I think Sheng Long, who works on this, he's an engineer on the team. He does this like on his downtime. This is his like passion project. He actually is one of the engineers who worked on this website called armviz.io, which he was, I think he might have been working for Microsoft at that point, but he wasn't on our team. And so we asked him to join us, and he was happy to join. So he still works on the visualizer when he can, even though we asked him to work on other things, he somehow finds a way to keep working on it. And he shipped like a lot of like nice extras, like zooming in and out and fitting to your canvas and all that sort of stuff. So it's pretty cool. Out of curiosity, oh, go ahead.
Oh no, go ahead.
What is being used to transpile Bicep into ARM? A lot of C# code, basically. So the Bicep CLI is the binary that we ship in our releases. It's a .NET application that takes the Bicep code, processes it, and emits an ARM template. We take advantage of awesome .NET Core capabilities, so we get cross OS, cross everything binaries that are small, and it's just a single executable that you need to install. So .NET, the advancements in .NET really made this project a reality for us because we have a ton of .NET expertise in-house at Microsoft, as you might imagine. All of our backend services in ARM are almost entirely in .NET. And so to be able to take that efficiency and apply it to this project and still have a native experience with native binaries that the ecosystem expects is just like, it's amazing. It's like too good, where we go too fast. So that's been pretty cool. Is there any way or plans to get Parser to change old ARM templates to Bicep? Yes. Stephanie, I don't know if your project has an ARM template in there. If it does, we might be able to show off the decompile command. Do you know if you have any JSON?
No,
okay.
I don't think, not that I can find.
Okay. So yeah, we have a command for this called decompile. So you can do AZ bicep decompile and point to an ARM template, and we'll do our best to turn it into Bicep code. It's not a perfect process. It's machine generated code. You may want to refactor things after the fact and things like that, but it gets you 90% of the way there. We'd recommend for at least a few of your ARM template files, if you have them, to kind of decompile by hand, just so you get a sense of like what it means to write Bicep code. What is the day-to-day going to feel like in terms of IntelliSense and validation? Obviously, if you need to just do things in mass and you want to use the decompiler for that, that makes sense. The other thing that you can do that is helpful is for these module instantiations. Right now, they're Bicep files, which is like the most optimal way to do that. But you can use a module with an ARM template JSON file, and we'll still do validation and we'll still give you IntelliSense. So a good way for customers to transition, if they're using ARM templates today, they can start by writing like a main.bicep orchestration file, and then just call all of their ARM template JSON files. And they'll actually get a lot of the goodness of Bicep, even just with that, in terms of validation and that sort of thing. So that can be really useful as well. Is the Azure portal going to start giving out Bicep templates as well as ARM templates? Today, what Kevin's talking about is there's a few ways you can get the ARM template of a given set of resources. One that a lot of people know about is this template export capability, which should have a big fat warning on the top of it saying basically this is like machine generated ARM template code, and it's not necessarily guaranteed to work, but it's a good way to like get all the properties and kind of see what a resource actually looks like. And then there's another way to get an ARM template, which is the better way to get an ARM template, is when you're creating a resource and you get to the review and create step in the portal, there's actually a link. It says download a template link for automation. That's actually the literal ARM template that we use to deploy your resources. And that's in one way or another basically hand authored by the resource provider team. So that ends up being a really clean and manageable template, and like just the right things are parameterized and that sort of thing. So that's the better way, just as a side note. Both of those are just ARM templates today, and certainly it would be nice if they were Bicep in the future. We have plans to do this, but we don't have this available today. Basically, we need to stand up an API that allows us to compile and decompile just through the API. And once we have that, the portal can then light up those kinds of features. So definitely want to do it, just not there yet.
All right, I'm going back to the PowerPoint. Can you guys see this? Cool. So our future releases, Alex, do you want to explain these?
No, go for it.
Okay, cool. It says November. I believe this has been moved to December, our version 0.5 release. This will be public module registries, and that's what our engineers have been working on for a while. it's going to allow us to be able to create these modules to be reused. And yeah, right now we have private module registries in which people can upload their own modules for reuse as well. Also, pass resource between module. I believe this is just an extra enhancement to the Bicep code. And version 1.0 is our strict breaking change policy. Is this still going to be in February, Alex?
Probably not.
Probably not. Okay. Probably going to be pushed back some more, which is fine. We just want to make sure that the code is as perfect as it can be, so nothing bad happens. Type updates separate between separate from core updates, and preview of Bicep extensibility Kubernetes in January, and Azure Active Directory in March. The extensibility is something one of our engineers, Anthony, has been putting a lot of time into. He just wants to make sure that this is our next step into my mind is blank right now, but next step towards what is that word, Alex?
And this will allow us to do kind of what we call end-to-end Azure deployments. So usually there's a non-ARM thing that you need to do, like creating a service principal in MS Graph or an AAD, or doing a deployment to an AKS cluster that you just stood up, that kind of thing. So this is a new adventure for us. You can loosely compare this to the Terraform provider model, but our goal is to really keep it very constrained to these specific scenarios. We don't really have an intention of having a broad provider ecosystem, but we will do these kind of targeted things where they make sense for doing Azure deployments. And then the other thing I just wanted to add here is, 1.0 in many ways is kind of a marketing exercise. The Bicep code base is pretty mature at this point. It is supported by Microsoft support plans. It is at feature parity with ARM templates, but there are a few things that we want to get done from a breaking change perspective prior to declaring 1.0. But we don't have any concerns with you taking a dependency on it. There's lots of folks who are using Bicep in production today. But to give you context on what that really means for us.
All right, so that is it. Like I said, you can install this in VS Code or go to our GitHub to learn more, as well as following Bicep link on Twitter for updates. We also have community calls, so definitely follow on that if you're interested. And you could join our Yammer, which we also post a lot of updates, pretty much similar to Twitter, but you can go to both. And that's all. Thank you, everyone. Any other questions? I think everyone has asked their questions.